So BC Kids, here comes section 9.5. It's integrating vector valued functions. In section 9.4 we did derivatives, and now we're integrating. Now you have to think about what integrating can help us with vectors. In other words, what would I be trying to find if I'm integrating a vector? And so hopefully you're thinking of position, and you're thinking of instantaneous rate of change. Is the particle moving right or left? What are the x values? You're going to see the word problems that come up with this whole thing. But anyway, if I've got a function and my function is r of t, it's a vector valued function where the x component is f of t and the y component is g of t. Then if I want to integrate them, the integral of r of t dt would be the vector that's created by the integral of f of t dt and the integral of g of t dt into a vector form. So it's just find the integral of each piece. Now all the old integral rules apply. Just like in the last section, all the derivative rules apply. So in this case, if the integral rules apply, then you need to think of things like u substitution. That's going to come up quite a bit. You're going to have to think about what's the integral of sine or cosine. Remember, you're working your way backwards. So with that in mind, let's try these couple little examples that they give us. Find r of t if the derivative of r of t is 4e to the 2t, 2e to the t, and r of 0 is this component with an x of 2 and a y of 0. It's kind of like, remember the old initial value situations? So what happens is you figure out the integral and you've got a plus c going on, but then they give you enough information, they give you an initial condition where you're able to actually calculate what c is. And so that's really the direction that we're going with these. So I look at this first, so I'm going to say, let me say it this way, r of t is the vector that's created by the integral of 4e to the 2t dt, and then the integral of the y component 2e to the t dt, and whatever that turns out to be, that's going to be what my r of t is. All right, so let's see. If I take the integral of this piece here, this is going to be a u sub, and I'm going to have to let u equal 2t. It's the only way I can get that power down. All right, so if I let u equal 2t, then du equals 2 dt. And so if I'm looking at this, that means that 1/2 du equals dt. So if I put that back together into this, for this one, that's going to give me 4e to the u times 1/2 du. Let's keep going with the x. Half of 4 is 2. 2e, we know that u is 2t, and I need a plus c. And so that's what the integral for that piece, the x component, would look like. 2e to the 2t plus c. Now the second one, I have a t as my power, and so I don't really need to go through all of this. It's just going to be 2e to the t I'll say dt. All right, so that means I have 2e to the t plus c. Well, there's my r of t vector valued function, but they gave me information for me to be able to figure out exactly what the c could be, because that comes here. They told me the x is 2. That component part equals 2. So now I come over here, 2 equals 2e to the 2. Now that happens to be when t is 0. This piece here means that t is 0. So t is 0. 2e to the 2 times 0 plus c is going to allow me to solve for c. If I look at this, I have e to the 0 is 1. 1 times 2 is 2. 2 equals 2 plus c, so c is 0. going to do the same thing over here. My y component is 0. 0 equals 2e, my t value is 0, plus c. E to the 0 is 1. 1 times 2 is 2. 0 equals 2 plus c, so c is a negative 2. Now with that information, I can put my vector together of what r of t actually is. I think I can squeeze it here. R of t equals the vector of 2e to the 2t plus 0, comma, 2e to the t minus 2. And that's it. So you just integrated the vector. All right, let's try this one. Find r of t if r prime of t is, secant squared t, comma 1 over 1 plus t squared. You got to think about your integrals, right? R of t, I'm going backwards. R of t. Whose derivative is secant squared? So you're going to find the integral of a secant squared t dt. You're going to find the integral of 1 over 1 plus t squared dt, and that's going to be your resulting integral vector. So let's see. If I go backwards, the derivative being secant squared, that means the function was tangent. Do you remember that? The derivative of tangent is secant squared. Whose derivative is this? Well, that one, it's one of your inverses. It's one of your inverses. I'm just checking my focus there. One of your inverses, and if you remember, it's the inverse of tangent. Oh, I forgot my plus c here. Hold on. Plus c. This one is going to be inverse tangent plus c. Did they give us an initial condition that we could figure out what c actually is? And the answer is nope, they did not. So that's your answer. There's your r of t. All right, now they're giving you number 3. This one is now find the integral between -1 and 1 for this guy. So let's figure out what the integral vector is first. So if I look at the integral vector, the integral of t cubed, I guess I'll keep doing it the way I was doing it. T cubed dt, and then I want the integral of t to the 1/5 dt. So I have an x component and I have a y component, and what I need to do is then evaluate them between -1 and 1. So I have, if I go integraling, remember you're adding a power on, dividing by the power, so this guy would be 1/4 t to the 4th, and I want to evaluate that going between -1 and 1. My y component, I'm going to put these separate and then we can put them back together in the end. My y component is going to be one more power on, so that's 5/5, that makes it 6/5, but I'm dividing by 6/5. Are you catching all this? I have 5/6 t to the 6/5 going between -1 and 1. I guess I could keep it in vector notation like this. All right, so plug it in. I get f of b minus f of a. I have 1/4 times 1 to the 4th is 1, minus 1/4 -1 to the 4th. Right, that's my x component. Let me keep going with that. I'm going to come over here. That would give me 1/4 minus 1/4. Whoa, that's a 0. Now I'm taking 5/6, 1 to the 6/5, minus 5/6, -1 to the 6/5. Well, that's going to be, this is 1, so it's 5/6 minus. And then this guy, if I have a -1, but I'm taking the 5th root of it, but then I'm raising it to the 6th power, it's an even power, it's going to be +1. So it's minus 5/6. And I get another 0. And there you go. There's my resulting integral for this particular guy going between -1 and 1. All right, we're going to pick a couple of practice problems and then we will call it a day. The first one that I picked is number 3. So let me find you number 3. This one, f of 0 is the vector 3, 1. F prime of t is 6t squared, and 4t is your vector valued function. So here's the question. The questions, I'm going back to the directions. For problems 1 through 6, find the vector valued function f of t that satisfies the initial given conditions. So the first thing I need to do is to integrate each piece. I need to know what f of t is. So I'm going to integrate a 6t squared, and I'm going to integrate a 4t. All right, let's do it. If I integrate this, then it's one more power on, so it'll be t to the third. 6t to the third divided by 3 is 2t to the third plus c. Actually, no, that's not true. Yeah, it is. Yeah, I'm skipping ahead here. 2t to the third plus c. And then my second one is going to be 4t squared divided by 2. That's a 2t squared plus c. You're just integrating each piece. Definitely old polynomial rule kind of thing. But then they give me a condition that this is my x and this is my y, this is my t. Right, so I'm going to plug all that in to find out what it's going to be for f of 0. When it's f of 0 is 3, 1, I want to figure out what the resulting c is going to be because of that. So I know that for this piece, x is 3, 2 times 0 cubed plus c. I'm plugging in my x and my t. This is 0, so c is 3. Gives me my, I'm looking for f of t. The x component is going to be 2t cubed plus 3. Go to the y component, it should be 1 equals 2 times 0 squared plus c, give me a c of 1. My y component therefore is going to be 2t squared plus 1. Actually, oh, did you catch that mistake? Here I am. Let me fix myself. All right, let me make this better. Sorry, kids, I'm looking at this for a second. 2t squared plus c. 2 I think I did my example problem wrong when I did it myself. So again, if I plug this in, 2t squared plus c, I think I'm going to go with what I said, that my answer originally was wrong. So t is 0. That's going to give me a 0 for this guy, so c is 1. All right, I'm going with it. Let me just say that when I originally did this, I said that c was -1. But I think I disagree with that, so c is 1. All right, that's number 3. Number 5 is next, and number 5 is a double doohickey. Number 5 is a double disaster, because look what they gave you. They gave you the second derivative. And if they gave you a second derivative and you're trying to get back to find the original, that means you have to integrate twice. So you're going to start with this second derivative, and you're going to go backwards. You're going to figure what x prime of t is and what y prime of t is. So you want to know what the integral of the x piece and the integral of the y piece actually is. Let's see. Integral of 5 cosine of t is going to be a 5. Integral of cosine is sine of t plus c. This guy is going to be a -2 sine, hold on a minute. Integral of sine is negative cosine, so that makes this a +2. Take away my negative. Cosine of t plus c. And now I can put in the initial condition, and I'm using this original one for the derivative. When t equals 0, x is 3 and y is 0. So here we go. x is 3. 5 sine of 0 plus c. Sine of 0 is the coordinate 1, 0. Sine is the y, so that's a 0. So this is 3 equals 5 times 0 plus c. Gives me a c that's 3. So my first derivative component for x is 5 sine of t plus 3. The y component, let's try him. He is going to be, in the first derivative, when y is 0 and t is 0, what happens? 0 equals 2 cosine of 0 plus c. Cosine is 1. 0 equals 2 times 1 plus c. Bring the 2 over. Negative 2 is c. Here's my y component for the first derivative. That would be 2 cosine of t minus 2. Well, that's lovely, except that's not the answer, because we want the original function, what f of t would be. So I've got to do this all over again. So I'm going to now take the integral of this guy. So I'm working my way towards x of t. That one's going to be a 5. The integral of sine is negative cosine of t plus 3t plus c. My y component is going to be 2 integral of cosine is sine of t minus 2t plus c. And they gave me up here what my information is for figuring out that initial condition, f of 0. That means t is 0, x is 0, y is 3. I'm going to figure out what c is. This is a 0 for the x, negative 5 cosine of 0 plus 3 times 0 plus c. Cosine of 0 is 1, so that means I've got 0 equals negative 5 times 1 plus c. Bring the c over, and c is 5. That means that for my f of t, I have the vector valued at, let me go here, negative 5 cosine of t plus 3t plus 5. There's my x component. The y component is going to be, let's figure this one out, y is 3, 2 sine of 0 minus 2 times 0 plus c. The sine of 0 is 1, so that means I've got 3 equals 2 times 1 plus c. That zeroes out. Gives me a 1 over here. And so my y component becomes 2 sine of t minus 2t plus 1. Oh, that's not true. Sine of 0 was y. This is a 0. Ooh. Good thing we're almost done. Sine of 0 is the y coordinate, so it's a 0. That means that this zeroes out and you get a c of 3, and that I agree with. All right. Number 7 happens to be next. We're on the roll with these odds. If I'm looking at this one, for t is greater than or equal to 0, a particle is moving along a curve, so the position at time t is x of t, y of t. At time t equals 1, the particle is at position 2, 4. It's known that d of x over d of t is the square root of t plus 3 over e to the t, and dy over dt is cosine squared t. Find the x coordinate of the particle's position at time t equals 5. Now position, and you're looking at, what are they giving you? They're giving you the derivative. So there's a whole lot of verbiage going on here. Don't get too crazy in it. You want the position at time t equals 5. In other words, you want the x coordinate of it. You want to know x of 5. All right, well, if you think about it, you know where it is at time t equals 1. At time t equals 1, you've got an x. You don't care about all the y parts of this. The y parts don't matter. They want the x coordinate. And so the x is 2. That's where it starts at t equals 1. But then you need to know what it's doing from 1 to 5. Right? You've got a time value from 0 to 5. You know where it is at 1, but you don't know where it is from 1 to 5. So that's where you're integrating. And you're only integrating the x piece because that's all you care about. You do not care about this y piece. It doesn't matter to us. They didn't ask about it. So it's the integral of t plus 3 square root e to the t dt. And so you go to your handy dandy calculator and you put all this into your calculator and you say, okay, thank you, Mr. Calculator, because my answer comes out to be 2.799. And that's totally just plugging it into the calculator, nothing fancy there. The last one I want to do is number 9. It's very similar, actually. So it says, at time t is greater than or equal to 0, particles moving along the xy plane has a velocity vector given by v of t, yada yada. If the particle is at a point 1, 2 at time t equals 0, how far is the particle from the origin at time t equals 2? Well, you know where it is at time t equals 0. And this word far, what does far mean to us? It means distance, right? The distance something is. So if I'm looking at this, and again, they give me the velocity vector, and I'm trying to get to a distance, which means I want to integrate that thing. So I have the x component and the y component that I'm trying to go backwards and figure out what that integral would be for this. And so if I do that, that means I have to figure out where it started at t equals 0, where my x component started at 1. So if that's the case, then I've got 1 plus. And that tells me where it is at 0. I'm trying to figure out where it is at 2. So that means that this guy goes 0 to 2, my integral. And that's going to be the integral from 0 to 2 of the x component of this guy, 3t squared dt. The y component is going to be similar. It's 2. Starts at 2, plus the integral from 0 to 2 of the y part of this. And so the y part of this is the 3. All right, if that's the case, let's check it out. My x component is going to be 1 plus, well, the integral of 3t squared is t cubed. I want to know what that is going between 0 and 2. Let's keep going with him. 1 plus f of b minus f of a. If I plug a 2 in here, I get an 8 minus 0. Gives me an x component of 9. Over here on the y side, I get a 2 plus. The integral of 3 is 3t going between 0 and 2. And if that's the case, then I've got y equals 2 plus 6 minus 0. Gives me a y component of 8. So it lands at, started at, I want to know how far it is from the origin, 0, 0, to 9, 8. And all I need to do is think the old distance formula. Now I know you haven't thought about that for a while, but if you think of the distance formula, it's a big old square root. X component, 9 minus the origin, 8 minus the origin, gives me the square root of 81 and 64. I go to my calculator, I get the estimation off the calculator, and your answer is 12.042. And that, my friends, is section 9.5. And so if you have questions, shoot me an email. Otherwise, I'll see you in class.